Hello everyone, welcome back to my channel. My name is Dr. Visaya Autopsy, and today I'll be taking us through another series of the Statistics Made Easy class. Kindly share, watch, enjoy as you watch, and also subscribe to my channel. God bless you. Today we'll be looking at measures of variation. Why study variation? Because of some of the disadvantages of measures of average. Because we are in measures of average, we are only looking for a single value that represents the entire data. It came with some demerits and limitation, and that is why statisticians propounded measures of variation. And why measures of variation? It helps to study the important characteristics of a distribution, that is the extent to which items vary from one another from that single value that represents the entire data, that is the central value. This will give us a better understanding of what we are talking about, this example. And looking at this example, it says this is best explained from this example below. If you look at series A, we have 100, 100, 100, 100, 100. Series B, we have 100, we have 105, we have 102, we have 103, and we have 90. For series C, we have 1, 4, 8, 9, 2, 3, and 5. If we take the mean of each of these series, mean for A series is 500 divided by 5, which is 100. Mean for B series is 500, adding all these values together, divided by 5, which is also 100. The mean for series C is also 500, that is adding 1 plus 489 plus 2 plus 3 plus 5 is also equals to 500. And our mean is bar x is equals to summation x all over n, that is bar x is equals to 500 all over 5, that is 100. But it doesn't stop there. What then calls for the variation? Looking at the three series, series A, none of the items deviated from the arithmetic mean, that is the arithmetic mean was 100, all the variables or values on that series was 100, 100, so there was no variation at all. For series B, there was a slight variation because some of the items deviated from the arithmetic mean. Only one item perfectly represented the arithmetic mean. The other item vary, but the variation was very small. Then series C, don't forget, for series C we had 1, we had 4, 89, we had 2, we had 3, and I think we had 5. So series C, there was no single value that represented the arithmetic mean, so the variation was much, and the dispersion between the values was much compared to even the other series. So this series C showed the extent to which variation or dispersion can go sometimes. Then coming to the objectives, what are the objectives of measuring variation? One of the first objective of measuring variation is to determine the reliability of an average, also to facilitate comparison between two or more things or two or more values. Then thirdly, to facilitate the use of other statistical measures. Then what are the properties of variation? I've only mentioned two, there are others, so you can look for others. One, it should be based on each and every item of the distribution. Then secondly, it should not be affected by extreme values. We'll be looking at the methods of studying variation. There are about 6 methods. The first one is called the range, the second is called the interquartile range, the third is called the quartile deviation, the fourth is mean deviation, the fifth is the standard deviation, and the last one of the series that we'll be looking at is called the variance. But there is one important thing for us to know, which is the range and the interquartile range and the quartile deviation are called positional measures because they depend on some values. They depend on the values at a particular position in the distribution. As we do examples, you understand what I mean by these positional measures the more. Then the mean and standard deviation are called calculated measures because all the values are employed in their calculation. We said there are 6 methods of studying variation, and the first method is range. What then is range? Range is the simplest or the easiest method of studying variation. And what is the formula of range? Range means the largest value minus the smallest value. Some other textbook or some other authors have classified range as the highest value minus the smallest value, depending. All we want to know is the bigger one minus the smaller one. Then also, what is the coefficient of range? Coefficient of range is just the formula of range in the opposite direction. That is, large value minus small value all over large value plus small value, depending on, it could be highest, it could be large, depending on how. But me, I have decided to use the large value minus the small value all over divided by large value plus the small value. A further illustration will give us a clearer picture on what I'm talking about. This is illustration 1 on range, and these are the days. We have 1, 2, 3, 4, 5, 6 days, and the prices in naira. We have 200, 210, 208, 160, 220, and 250. Then the question says calculate range and the coefficient of range. Then solution, we said the formula for range is the largest value minus the smallest value. So looking at this, the largest value is 250 naira. So come here, I wrote 250 naira minus the smallest value. The smallest value here is 160. So 250 naira minus 160, our range is equal to 90 naira. Then the next question says coefficient of range, and the coefficient of range means the largest value minus the smallest value all over the largest value plus the smallest value. That is 250 minus 160 all over 250 plus 160. That is 90 divided by 410. Our coefficient of range is 0.22 naira. Okay, illustration 2 says calculate the range and the coefficient of range from a group data, as we can see. Then we have the max and the frequency. The max is 10 to 20, 20 to 30, 30 to 40, 40 to 50, then 50 to 60. Then the frequency is as follows: 8, 10, 12, 8, 4. Adding all these together, 8 plus 10, that's 18, plus 12, that's 30, plus 8, that's 38, plus 4, that's 42. Then how do we solve it? There are 2 ways in solving range or the coefficient of range from a group data, and these are the 2 methods on the board. 2 methods of determining range from a group data. The first one is to find the difference between the upper class limit of the highest wage, the upper class limit of the highest wage, and the lower class limit of the lowest wage. The upper class limit of the highest wage. What is the highest wage? The highest wage, to find the difference between the upper class limit of the highest. The upper class limit of the highest is what? Is 60. The highest mark, rather, not wage, the highest mark. Let me clean this and rewrite. The highest mark, not wage. The highest mark. The highest mark, not wage. The highest mark. The highest mark. So the first method is to find the difference between the upper class limit of the highest mark and the lower class limit of the lowest mark. The lowest mark, not range, not wage. The lowest mark is the lowest mark. Lowest mark. So looking at the highest mark on the board is 60. So I have 60, and the lowest mark is 10. The lower class limit of the lowest mark, which is 10. So our range is 60 minus 10. That is equal to 50. And of course, the coefficient of range will be 60 minus 10 divided by 60 plus 10. That is equals to 60 minus 10 is 50, then 60 plus 10 is 70. So dividing 50 divided by 70 is equals to 0.714. Then the second method is to what? To subtract the midpoint of the lowest mark. The midpoint of the lowest mark from the midpoint of the highest mark. The lowest mark on the board is between 10 and 20. And looking at the midpoint is lower class interval plus upper class interval divided by 2. And the lowest mark, the midpoint will now be 20 plus 10. The lowest mark, 20 plus 10 divided by 2, which is equal to 15. We said subtract the midpoint of the lowest mark from the midpoint of the highest mark. And the highest mark is what? Between 50 and 60. So the midpoint will be 60 plus 50. That is equal to 110 divided by 2. That is 55. Then looking at the range, it will be 55 minus 15. That is equal to 40. Then the coefficient of range will be 55 plus 15 divided by 55. 55 minus 15. 55 minus 15 divided by 55 plus 15. That is 40 all over 70. And that is equal to 0.5. The merits and the uses of range. One of the merits of range is it is simple. It is the simplest of all the methods of variation. Then it is also easy to compute. Then secondly, another merit is that it takes minimum time to calculate it, as we saw in the previous example. Then what are the demerits? One of the demerits is that it is not based on every item of this distribution, and one of the rule of variation is that it should be based on every item of the distribution, but it is not based on every item of the distribution Don't forget, before I said they are called positional measures because they depend on one particular value or the other in the distribution. Then another demerit is it cannot be computed in cases of open-end distribution. Then what are the uses of range? One, for quality control in organization, companies, schools, institutions, range can be used for quality control. Then secondly, range can be used for weather forecast. Maybe because it just rained here, it can be used for weather forecast. The next method of studying variation, which is the interquartile range and the quartile deviation. Interquartile deviation and the quartile deviation. The interquartile deviation is the difference between the third value and the first value, or the third value and the first value. A better explanation would make us to understand this. And the interquartile range is Q3 minus Q1. Then the quartile deviation is Q3 minus Q1 all over 2. Then the coefficient, as usual, is Q3 minus Q1 all over Q3 plus Q1. We'll be looking at an illustration on individual observation before we look at continuous series. We'll be looking at the individual observation, and this is the illustration. Find the quartile deviation and the coefficient. These are the numbers 1, 2, 3, 4, 5, 6, 7, and these are the marks 20, 28, 40, 12, 30, 15, and 50. And the solution, okay, how do we solve it? Starting with the solution, the first step is to what? To arrange these marks in ascending order. The numbers we have is 1 to 7. 1, 2, 3, 4, 5, 6, 7. So I've arranged the marks in ascending order: 12, 15, 20, 28, 30, 40, and 50. Then Q1 means quarter 1. Like we did for median, median is n plus 1 over 2, the middle value divided by 2. Q means quarter, so divided by 4. 4 is quarter, so it means n plus 1, nth item divided by 4. How many items do we have? We have 7 items, so we have 7 plus 1 divided by 4, nth item. Then 7 plus 1 is equals to 8. 8 divided by 4, it means the second item on our marks. And the second item is what? As I have circled out, the second item is what? The mark is what? 15. So the mark here is 15. Then Q3 is 3 into bracket n plus 1 all over 4. Just quarter 3. A quarter, the 3/3 of 3 quarter. So it will be 3 into bracket n plus 1 all over 4 nth item. So 3 into bracket 7 plus 1 divided by 4. That's 3 into bracket 8 divided by 4. That will be 8 divided by 4 will give us 2. That will be 3 times 2. That's the 6th item. And looking at the board, the 6th item is what? The 6th mark is what? Is 40. So I've circled it out and I wrote 40. Then solving the question now. The first question says interquartile range. Interquartile range, the formula for interquartile range is Q3 minus Q1. The value for Q3 is 40. Then the value for Q1 is 15. So that will be 40 minus 15. That is equal to 25. That is our interquartile range. Then quartile deviation is what? Q3 minus Q1 divided by 2. That's 40 minus 15 divided by 2. That's 25 divided by 2. That's 12.5. Then the coefficient of quartile deviation will be Q3 minus Q1 all over Q3 plus Q1. That's 40 minus 15 divided by 40 plus 15. That's 25 divided by 55. That is equal to 0.455. So the next series we'll look at, like we said, that for each of these topics, we have individual series, we have discrete series, and we have the continuous series. So we'll be looking at the discrete series for interquartile and quartile deviation, and we have 10, 20, 30, 40, 50, and 60 as the mark. Our frequency is 4, 7, 15, 8, 7, and 2. Adding it up, we have 43. But like we did for median, the next thing after our frequency is to look for the cumulative frequency, and the first one automatically we get the answer for the first one to be the same answer because we add it up with 0. So we say 4 plus 0, we have 4. Then 4 plus 7, we have 11. 11 plus 15, we have 26. 26 plus 8, we have 34. 34 plus 7, we have 41. 41 plus 2, we have 43. Then going into the question, the quarter Q1 is equal to n plus 1 all over 4. That our n's value or our n value is 43. So 43 plus 1 divided by 4. So 43 plus 1 is 44 divided by 4. So the Q1 is the 11th item, and the 11th item on the board. It means from the cumulative frequency, what is the first value that can conveniently take 11? And thank God we have 11. So 11 is taking 11, and the max for 11 is what? 20. So we do the same process for Q3. Q3 is 3 into bracket n plus 1 nth item divided by 4, or n plus 1 divided by 4 nth item, that is, and n plus 1 divided by 4, we add 11. So 3 multiplied by 11, it means the 33rd item. And it means that from the cumulative frequency again, what value can conveniently take the 33rd item? Looking at the cumulative frequency, the first value that can conveniently take 33 is 34, and the mark under the mark under 34 is what? 40. So solving the question, the interquartile range formula is Q3 minus Q1. That is, Q3 is 40. Our value here is equal to 40 marks, and our value here is equal to 20 marks. So interquartile range now is Q3 minus Q1. That's 40 minus 20. That is what? 20. Then quartile deviation is Q3 minus Q1 divided by 2. That's 40 minus 20 divided by 2. That's 20 divided by 2, and we have 10. Then the coefficient of quartile deviation is Q3 minus Q1 all over Q3 plus Q1. That is 40 minus 20 divided by 40 plus 20. That is 20 divided by 60. That is 0.33. For continuous series now, this is another illustration on interquartile and quartile range, but on continuous series we have acres between 0 to 40, 40 to 80, 80 to 120, 120 to 160, 160 to 200, 200 to 240, then 240 and above. Then the frequency of 394, 461, 391, 334, 169, 113, 148. Then like we said, that the next thing is to add up the values, and that is cumulative frequency. The first value will be added plus 0. 394 plus 0, we have 394. Then 394 plus 461, we have 855. 855 plus 391, we have 1246. 1246 plus 334, we have 1580. 1580 plus 169, we have 1749. 1749 plus 113, we have 1862. Then 1862 plus 148, we have 2010. And what is Q1? Automatically, because it is a continuous series, Q1 becomes n over 4 nth item, or over 4 nth item. Then the n is 2010. Then 2010 divided by 4 nth item, we have 502.5 nth item. 502.5 fifth item. So the first thing we look at is where 502.5 can conveniently lie. Looking at the first cumulative frequency, we have 394. You can see that 502 cannot contain that. Then the next value is 855. So the first value that 502.5 can conveniently take is what? 855. So Q1 lies within this hectares of land between 40 and 80. Then Q3, since we know the value of n over 4 to be 502, so we just say 3 multiplied by 502.5, that is 1507.7 item. We are still also going to look at the value or the acres where 1507.7 can conveniently sit, and that is 1580. That is where Q3 lies. It doesn't end there. We have to find the value of Q1 and Q3. Looking at the value for Q1, the formula says L is the lower class limit of that class where Q1 is sitting, plus n over 4 minus cumulative frequency of the preceding class divided by the frequency of that class multiplied by the class intervals. So the lower class interval for Q1 is 40. So 40 is written here. Then n over 4, as we calculated, 502.5 minus cumulative frequency of the preceding class, that's the law. So 394 divided by the frequency of that class, 461, multiplied by the class interval. The class interval is the upper class interval minus the lower class interval, which is 40. So 40 plus 502.5 minus 394 is 108.5. Then multiply by 40, we have 4340 divided by 461, we have 9.41. So 40 plus 9.41 is equal to 49.41. Then Q3, the same method we have used for Q1, we repeat for Q3. Q3 is now lower class interval of Q3 is what? 120 plus 3 into bracket n all over 4, which is 1507.7 minus cumulative frequency of the preceding class, 1246, multiplied by the class interval. The class interval is the upper class limit, or the upper class interval minus the lower class interval, which is 160 minus 120, which is 40, divided by the frequency of that class, which is 334. So 1507.7 minus 1246 is what? 261.7, multiplied by 40, we have 10,468, divided by 334, we have 31.34. That is 120 plus 31.34, that is 151.34. That is, our interquartile range now is equal to Q3 minus Q1, that is 151.3 minus 49.41, that is equal to what? 101.8. 50.93. Quartile deviation is Q3 minus Q1 divided by 2. That is 101.93 divided by 2. That is 50.97. Then it also comes with its own merits and demerits. What are its merits? One, it is superior to range, so it has an advantage over range. Then secondly, it is also useful in badly skewed distribution. Then what are the demerits? One, it ignores about 50% of the values or item. Then secondly, it is not capable of the mathematical manipulation. Thank you. I hope you enjoyed this video. I'll be expecting your comments in the comment section below. Also, kindly subscribe to my channel, and God bless you as you watch. Also, share this video so that other people can also benefit. Thank you.